Hey everybody, we are in lesson 7-4 on rectangles in the Tennessee Revealed Geometry, and I am on page 429. Well, I guarantee you have seen a rectangle before in your life because it is talked about in all the lower grades. But of course, being high school geometry, we're going to probably get into way more detail about what a rectangle is. But it does have four sides. It is a part of the parallelogram family. So your opposite sides are parallel. Your opposite sides are equal to each other. Your opposite angles are equal to each other. In fact, they are all 90. The four angles add up to be 360. Let's see what else. Consecutive angles, 90 and 90 make 180. And the diagonals not only bisect each other, but they also are all four going to be equal to each other. So I'm talking about like AC and BD, and where they intersect somewhere right there in the middle, all these little bitty sections are the exact same. So what you're actually looking at are isosceles triangles. Isosceles all the way around. All right. I don't know if we're going to see a problem like that, but well, yeah, there it is. Okay. So this is what I'm saying. This diagonal BD and this diagonal CF intersect at G. And what I mean is BG, CG, DG, and FG are all equal to each other on a rectangle. That's not necessarily true in a parallelogram. They just bisect each other. All right. Let's see here. Example number 1. The coach is making the basketball team run a new drill along the diagonals of the court as shown. BC, that is your top side, is 94. FC, which is the diagonal, is 106.5 feet. Find DG. All right, we're looking for this right here. Okay. Well, yeah. Okay, so FC is the diagonal. What I'm going to do is bisect that. That means I'm going to take 106.5 and divide by 2 to find out what each one of these sections is, C to G and F to G. And because it is a rectangle, it will be the same length from D to G. All right, so let's see what they want us to put here. So I'm on the bottom of page 429. And let's see, FC is congruent to BD. So I'm going to come in here and put BD. And I need a bar over it. I think that's the one. So small. All right, so FC is equal to BD. So let's see, BD will be 106.5. And they want us to divide that by 2. They just go the long way around explaining it. So half of 106.5 is 53.25. So what you just found actually is BG, CG, DG, and FG. They are all 53.25. Okay, let's see what's going on. Let me turn the next page to the check. All right, J is framing a barn door with an X brace as shown. Okay, so RT, well, I see R. Oh, there's T. That's where they intersect. RT is 3 9/16 feet. So that means ST, PT, and QT are all 3 9/16. All right, so QR, that's the right side of the barn door, is 7, which means PS is 7. Okay, and angle RTS, this little bitty angle that I'm pointing to is 65 degrees, which means this angle on top is 65 degrees. And the reason is because vertical angles are equal to each other. All right, find the measure. Find each measure. All right, so then wants to find a bunch of stuff. If the measure is not a whole number, then write it as a decimal. Well, okay, no problem. So PS. Well, PS is the left side of the barn door. And since QR is the right side and it's 7, PS is 7. Okay, SQ. SQ is the length of the full diagonal. And what I need to do is take RT, which is half because it was bisected, and double it. Y'all, that means I'm going to multiply it times 2. So take 3 and 9/16. And I'm just using my calculator. And we'll multiply times 2. So I get 57/8, but they want it as a decimal apparently. So it's going to be 7.125. Moving on, QTR. QTR. Well, this obtuse angle is the one adjacent to the 65 degree that they said RST is. Well, if you remember our rules in geometry, these are supplementary angles. They add up to be 180. So I'm going to take 180, subtract 65 to find the supplement to it, and that's going to be 115 degrees. And last but not least, TQR. TQR is this angle. Well, if you paid attention to what I just said a second ago, all of these are isosceles triangles. What that tells us is this angle Q and the angle R in this isosceles triangle are the same. They are equal to each other. Well, since I know that the obtuse angle is 115, the trick is take 180, subtract 115, and then you're going to divide that number by 2 because the other two angles are 180 when you combine with the 115. All right, so I'm going to take 180, subtract 115, I get 65, divided by 2, and I get each one, Q and R are 32.5 each. All right, so I'm done with that check. Oh, let's move on to example number 2. All right, we got a quadrilateral ABCD, which is a rectangle. Angle BAC. For you visual people, that's this angle. This little skinny one is 3x plus 3. And ACB, this angle where C is, because that's the vertex, the letter in the middle is 5x minus 1. Find the value of x. Okay, well, listen, this is a right triangle, ABC. I know it's a right triangle because on a rectangle, angle B is automatically 90 degrees, which tells us that this angle A and angle C in that right triangle add up to be 90 degrees. All right, so this is a rectangle and it has right angles. Oh, 4. Let's go with 4 right angles. So let's see. DCB equals 90. Okay. Because the rectangles are parallel, opposite sides are congruent. Alternate interior angles of parallel lines are congruent. So ACD and BAC are equal to each other. Okay, but that is not the angle they gave us in the problem. ACD and ACB. So I'm kind of curious why they were saying that, but okay, I'll go with it. So they're saying that this angle and this angle are equal to each other, so these will add up to be 90. Okay, so let's use a different rule than I did. No problem. Same result. You're going to add those together to equal 90, and they don't give us any space to do that. So let me pull up my teacher notes. All right, so 3x plus 3 plus 5x minus 1 equals 90. Like terms, everybody. I'm talking about that 3x plus 5x. That is 8x. Also, like terms are 3 minus 1. And 3 minus 1 is 2. Equals 90. All right, I'm going to subtract 2 to the other side. And 90 minus 2 is 88. Oh, and I put 99. How about 88? And the opposite of multiplying by 8 is to divide by 8. So 88 divided by 8 is 11. X is 11, everybody. X is 11. All right. So we are now going down to the bottom of the same page in your workbook, page 430. All right, we got a quad. It's a rectangle. MN is this little bisected part of the diagonal, JL, oh, the full diagonal. It's a trick question. Find MK. All right, well, no problem. All right, so it takes 2 of the MNs, because that would be a total of MK, to equal JL. Again, these diagonals are equal to each other, so JL is equal to MK, but because they try to trick us with that MN, it takes 2 of these to be a full MK. All right, so I'm going to do 2 MNs equals 2x plus 9. 2 of the 3x plus 1s equals 2x plus 9. All right, you guys, if you're a brand new teacher, sometimes visual students will have a hard time seeing that, so you might want to demonstrate that to them a little bit better than I can. It won't let me really do much with this figure right here. All right, so you can either distribute or just go ahead and divide by 2. Most students who are coming fresh out of Algebra 1 are going to feel more comfortable with distributive than getting that fraction. So we're going to do 2 times 3x is 6x, and 2 times 1 is 2. And that's going to equal 2x plus 9, so I'm just going to bring that down. All right, I like to move the small x, and most of the algebra teachers that I've ever talked with like to subtract the small x. I'm going to subtract 2x to the other side. So minus 2x here, minus 2x on the left. 6x minus 2x is 4x. I'm just going to bring down the rest of my problem. All right, now I got my x's combined. Let's combine our numbers. The opposite of adding 2 is to subtract to the other side of the equal sign. So minus 2, and then minus 2 from the 9. And 9 minus 2 is 7. Okay, the opposite of multiplying by 4 is to divide by 4. All right, and if you are panicking already, knowing I got a decimal, yeah, I'm about to get a decimal too. All right, so it's going to be 1.75, and that's going to be your x. And it looks like we're going to do a little plugging and chugging. So y'all don't freak out, all right, unless I made a silly mistake, which, of course, I can. I'm human. You're going to get decimals on this. So, yeah, just watch out for that. So I got 1.75. Now that's x. All right, they want me to plug in to find MK. Well, MK, the full diagonal, will be equal to the JL. So I'm going to take my 1.75 and plug it into the 2x plus 9. If you plug it into this one, don't forget to double it at the end. All right, so let's see. 2 times 1.75, and then we're going to add 9. Looks like we're going to get 12.5. All right. Okay, this looks like we're doing part A. Moving on to part B. Oh, it's sitting around to the nearest 10th. Okay, good, I did that. I just realized that. All right, part B, they want us to find angles. Let's see what angles I have. J, N, K. Just follow the dots. Connected. J, N, K. That's this big obtuse angle right there. Obtuse means bigger than 90, y'all. JNM. JNM is the one right beside it, the adjacent angle, this acute angle right here. Well, adjacent angles that make a straight line are supplementary. They're going to add up to be 180 degrees. So we're going to have to add these together to be 180. Y'all, hang on a second. I got somebody walking into my room. All right, sorry about that, you guys. Okay, back to it. All right, so what was I saying? These add up to be 180 degrees. All right, so let me pull up my teacher notes and get rid of this. All right, so I'm going to add them together. 5x plus 2 plus 3x minus 6 equals 180. All right, like terms, 5x plus 3x is 8x. And 2 minus 6 is a negative 4. Or you can just put minus 4 equals 180. All right, the opposite of subtracting 4 is to add 4. So I'm going to add 4 to the other side and get 184. And the opposite of multiplying is to divide. So we're going to divide by 8. And you get 23. All right, guys, this is the number you're going to plug and chug. All right, so 23 in for the X to find angle N. I'm sorry, J and K. And then 23 in for the X here to get the other angle N, J and M. All right, here we go. 5 times 23. And then plus 2 would be 117 degrees. 3 times 23. And then minus 6 is 63. If you want a good way to check, just add those together and make sure that they add up to be 180 degrees. That's a good way to check if you've done something right or wrong. And you know, I'm the first person who'll make a silly mistake. So, all right, moving on to the next page. All right, so let's see here. We got example number 3. Okay, well, we got a diagonal is a parallelogram are congruent, and the parallelogram is a rectangle. Well, not necessarily, because it could be a square. Yeah, I have a feeling we're going to talk about that another time, though. All right, example number 3. Prove rectangular relationships. All right, so it says AB is 50. Well, y'all, that means DC is 50. BC is 20. Well, y'all, that means AD is 20. CD is 50. I've already said that. AD is 20. I've already said that. All right, AC is 54. All right, there's your diagonal. AC is 54, which means BD is 54. All right, prove that it's a rectangle. Okay. All right, so AB is equal to CD, DC equals AD, AC is equal to BD, and they're all congruent. So is a rectangle because AC and BD are congruent diagonals. ABCD is a rectangle. You're kidding me. Okay. I still don't like that. I mean, I technically could be a square. You know what? I'm gonna leave that alone. Let's go to the check. Oh, the check is a proof. Haha, skipping it. All right, example number 4 on the next page. Looks like it's actually done for us. What are they doing here? They're trying to do the distance formula to prove that the opposite sides are congruent. Okay, so it looks like they did the distance formula for GH and KJ, and they were the same. They did the distance formula for GK and HJ. They are the same. All right, so opposite sides are congruent. So they're saying it's a rectangle. Oh, okay. All right, let's check. Ooh, interesting. You know what? I think I'm going to do GeoGebra on this. Most of my students are visual. And since I'm really doing this for my students, yeah, let's do this on GeoGebra. I got it pulled up. I was wondering if I was going to need it. All right, so let's go. And, oh, I didn't even look. 2, 6, 3, 7, 6, 4. I need it at least all in quadrant 1, 6, and 7s. So let me move this a little bit. So I go to 6 and 7 in either direction. All right. Okay, here we go. All right, A is 2, 6. That's right 2 up 6. B is 3, 7. That's right 3 up 7. All right, C is 6, 4. That's right 6 up 4. All right, so it's asking me where the 4th point is. Well, it looks to me like it's going to be about like right there, because that looks like a rectangle. But let's do this. All right, 5, 3. Right 5 up 3. Yeah, most definitely not. Not a rectangle. All right, 5, 2. That's right 5 up 2. Yeah. Oh, I was in the wrong spot. 5, 3. 5, 3 is the rectangle. All right, there you go. Sorry about that. I had 5, 2. I looked at the wrong one. All right, well, so let's back up just to show. Well, I didn't mean to do that. All right, so 2, 6, 3, 7, 6, 4. All right, so we can see 5, 2 is not correct. 4, 3, not correct. And 6, 3, definitely not correct. So the answer was 5-3. Sorry, guys, I apologize. I said A, but I looked at B when I looked down at the book. All right, so it looks like the answer is A, 5-3. Over 5, up 3. There's your last one. All right, you guys, looks like I am done. If you need some extra practice problems, you can go online and get those. And I hope you guys have a great day. If you have any questions, let me know. Ask your teacher. We love it. Y'all have a good one. Bye.